Hello everyone, I am Kritika Gupta, BTech Engineering Physics third year student, and the topic of my video PPT is ASCII to hex conversion and hex to ASCII conversion using 8085 microprocessor. So let's first see what are ASCII and hex numbers. ASCII, abbreviated as American Standard Code for Information Interchange, is a character encoding standard for electronic communication. ASCII is a 7-bit character set containing 128 characters, and we can represent 0 to 9 digits, small case letters and uppercase letters using ASCII, and some special characters also. And hexadecimal is a numbering system with base 16. It contains 0 to 9 digits and A to F letters. So instead of 10, 11, 12, 13, 14, 15, we use A, B, C, D, E, F. Now let's see the conversion. So in hex to ASCII conversion, a ASCII code is given to the algorithm, and as a output, the corresponding hex number is or the letter is stored. Now let's see the algorithm. First of all, the given ASCII code is loaded in the accumulator. Then 30 is subtract from it, and then the it is compared with 0A. And if the content in the accumulator is less than A, then it is stored at a specific memory location, and if it is equal to or greater than A, then 7 is subtracted from it, and then it is stored into a memory location, and then the program is terminated. Now let's see, for example, 31 is given as input, and it is the ASCII code. So first of all, it is loaded into the accumulator. Then 30 is subtract from it, which gives the answer 1. Then it is compared with 0A. Since 1 is less than A, so carry flag bit is set to 1. Now next instruction is jump to skip if is there a carry. So the instruction jumps to the skip label, and then 01 is stored into 4201 memory location. This is the code, and since these are stored as decimal numbers here, so here's the conversion. 49 in decimal is equivalent to 31 is hex, and we have used 31 as input, and it can be seen 1 is stored at 4201 location. Now let's compare our result with the table. In this 31 is equivalent to 1, and hence our answer is correct. Now let's see another example, 45. So first 30 is subtracted from it, which gives the answer 15. And in the next instruction, since 15 is greater than A, so carry flag bit is reset. So it doesn't jumps to the skip label. Then 7 is subtracted from 15, which gives the answer as 0E. And then 0E is stored at 4201 memory location. Let's see its code. Since 45 in hex is equivalent to 69 in decimal, so 69 is given at 4200 memory location, and as the answer 14, we get 14, which is equivalent to E in hexadecimal. Now let us again cross check our answer from the table. So here 45 is equivalent to E. So again our answer is correct. Now let's see hex to ASCII conversion. The given data is loaded into the accumulator, and it is also moved to register B. Then we mask the upper nibble, and the ASCII of the ASCII of the lower nibble is calculating using a subroutine. Then it is stored in the memory. Then again the content of the register B is loaded into the accumulator, and this time lower nibble is masked. Then through rotation of the bits, the lower nibble is taken to the upper nibble is taken to the lower nibble position. Then again to calculate ASCII ASCII number, the subroutine is called, and then it is stored into the memory location, and then program is terminated. Now let's see an example. Uh, for example, let us take E4 as a hex number for which we have to calculate the ASCII code. Now, then first the content of the accumulator is moved to the register B. Now A and B both contains E4. Then the upper nibble is masked using ANI 0FH. Here 0F is ended with our data. So since and with any other number gives 0, sorry, 0 with 0 ended with any other number gives 0. So so our upper nibble is masked. Now we call the subroutine call sub1. Here the number is compared with 0a. So since we have 4 and 0a is and 4 is less than 0a, so carry flag bit is set to 1. Then next instruction is jump, carry, skip. So we jump to the skip label where 30 is added to the number, so we get 34, and then it is returned and stored, and then it is stored at memory location 4201. Then again we move the content from the B register to the accumulator. Then again accumulator have E4 as the data. Then this time we mask the lower bit using F0. So since 0 ended with any number gives 0, and F ended with any number gives the same number, so we get E0. And using rotation using RLC, bits are rotated, so the upper nibble is shifted to the lower nibble. Since we need to shift it 4 times to exchange the nibble, so RLC is written 4 times, and hence we get a 0EH. Then again the subroutine is called, and this time since E is greater than A, so carry flag bit is reset and no jump occurs. Then 07 is added, so 7 plus E gives 15 in hexadecimal. Then again 30 is added, which gives 45 as hexadecimal. Then return, and then it is stored at a memory location 420 to 45. Then the program is terminated. And this is the implementation. Since E4 is equivalent to 228 and decimal, so 228 is given, and we get answer as 52, which is equivalent to 34 in hexadecimal, and 69, which is equivalent to 45 in hexadecimal. And I have mentioned the conversion here also in comments. Now let's check if our answer was correct or not. For E we get 45, and for 4 we get 34. So hence the code we have implemented is correct. Thank you.